Hello everyone and welcome. Now before we go ahead, as mentioned in this accompanying blog somewhere here, for most of your customers, Google Cloud's Vertex AI capabilities should be your first choice to build AI applications. Now this blog and the demos here are applicable to a certain type of customer profile who has stringent data protection requirements. And again, this blog actually talks about such customers in much more details, right? All right, so this video is going to get a bit technical pretty soon, but before we do that, and so that you don't really run away, let's take a sneak peek at what is RAG, or Retrieval Augmented Generation, and then also take a look at one of the demos. Now later on we're going to come back to the slide deck, and anyways, all right, let's see what is RAG. So let's say I ask this question, which is, how did the Sensex do today to an AI model, or in this case BARD. Now Sensex is Indian Stock Exchanges Index, right? So let's say if I ask this question, not just BARD but any other AI model won't be able to answer that question, because the model was trained a while back and does not know what happened today, right? Notice in this case BARD actually requires that it needs some context information to actually answer that question. So let's give that information. So what I did was I went to a website and kind of found out how did the market fare today, and took this information just like that. Like, this could have been a bigger information as well, but for the demo purpose I picked up this information and went ahead and changed my prompt. So notice that now what I've asked is, please answer only based on the context below. If the answer is not in the context, respond with I do not know, right? And context is basically the information that I retrieved from here, right? And then I asked the question, how did the Sensex do today? Now with this context, it's actually able to respond saying, hey, Sensex actually performed well today, right? So this basically in essence is what is retrieval augmented generation. What we are doing is we are retrieving some information which is going to help the model do its generation of the response, right? Now again, we're keeping things very simple here. RAG is a lot more complicated. There are a lot many videos which actually go into a lot more details of RAG, but here for the purpose of what we want to show in this video, this information is good enough. Now we can do something interesting, like we can ask with this context, why is the sky blue? And then the model responds saying, I don't know, because it actually could understand this. If there were this context was not given, from whatever it has learned till now, it could have answered why the sky is blue. But with this context, which is very specific to, let's say, Indian markets on a particular day, it really won't answer it, right? But of course, if there is no context given, it does go ahead and answer that question, right? So RAG can be used in various scenarios by a customer. So let's look at a simple RAG application I've built, where an organization wants to question their internal company information, which is across various text, PDFs and HTML documents. So the name of the org is basically Acme International, which works with various governments around the world. Of course, this is a fictitious company. And fun fact, do you know what ACME stands for? It stands for a company that makes everything. It's like a placeholder name that I'm sure some of you have come across many demos. All right, so let's go ahead and ask it a question. So what does ACME do? So notice that it actually responds with that it empowers governments to anticipate and protect against emerging threats. It also says that this information was found in about.txt file, and the model that was used to generate this response was Flan T5 from Google, right? So here is that model. Okay, so now Before we go any further, let's look around here. So if we go here, notice that this application has just one sort of a file that we have loaded, right? And then we were able to ask questions to it. Now, what we can do actually is go back into the application and look at what context was provided to answer this question, like what does the organization do. So let's go ahead and quickly do that. So notice that here is the full prompt. So it says only answer based on the context. If you don't know, say I don't know. And the context is basically pulled from the file. And somewhere here is the information that tells about, so this is actually the information like empowering governments to anticipate and protect against the emerging threats, right? So that's basically how the model was able to respond, because it actually got the context. Now we're going to go into a little bit more details of the RAG a little bit after, but let's go ahead and ask it, why is the sky blue? Okay, so why is the sky blue? Just like how we asked Bart. So notice that it says I don't know, right? And that's the expected answer, because based on the context it really wouldn't know, right? Okay, so now we want to ask it more questions like how was the Q1 and so on. So we need to load more of the customer's proprietary information into the application. So before we do that, let's understand how RAGs really work, or retrieval augmented generation, right? Let's look at a standard RAG architecture. All right, so here we start by loading the proprietary data, for example, company information, into a vector database, which is used for semantic search, right? Then when you ask the question, all the relevant data pertaining to that question is retrieved from the vector database. And we saw this earlier in the demo, right? And we're going to go back to that demo, but we saw how when we asked what does the Acme company do, it was able to pull some information out, and then the model actually looked at that information to generate its response, right? So what actually happens is all the relevant data pertaining to that question is retrieved from the vector database. So we kind of call it as context data, and that data is then provided to the model, along with the original question. And then the model answered the question using the provided context. We saw this earlier in the demo. So for example, in this particular diagram, and we're going to actually ask the model this question later on, right? So what was the revenue for Q1 was our question, and then basically what happens is the retrieval part retrieves from the vector database, let's say the Q1 report, and then hands it over to the inferencing model, and then the inferencing model basically then responds with whatever were the Q1 figures, right? Now for the customer, the elements of this architecture, including the vector DB, the inferencing model itself, are generally provided as API endpoints on the cloud provider like Google or Azure or AWS, right? So again, we are going to go back to the demo soon, so hang on, but this is kind of important, right? Now, for some customers, this is a problem because certain compliances and regulations do not allow them to hand over all their data to an API-based vector database and a model. Notice that all the areas marked in red here are out of the customer's control, and some customers are not okay with that. Moreover, sometimes the customer actually wants to run their own fine-tuned model with the models that are fine-tuned with their proprietary data in an infrastructure that is isolated and controlled by them, right? So now what's the solution, right? Now, well, on Google Cloud, the customers can choose to run their own models, right, on a confidential compute instance, which is what we have shown here, where the RAM of the instance is encrypted, which does not allow the cloud provider access to the instance. Moreover, the disk is encrypted with the external key, and the data for fine-tuning or for RAG use cases is end-to-end encrypted with ubiquitous data encryption, which we are going to see a little bit later, and can only be processed on on a confidential virtual machine. So that I mean that is basically the solution in a nutshell. But and I really promise you this is going to be the last slide before we go back to demoing, but this one is kind of important, so just hang on with me here. So this is kind of the full architecture of the application which we are going to continue demoing, right? So what we have on the extreme right here is a confidential compute engine VM or maybe VMs, right? And they are basically running the vector database, the model, and also the RAG code which glues this the vector database and the model together, right? And when you want to load the vector database, for example, which is what we are going to do a little bit later, the data is client-side encrypted using an external key and then exported to the Google Cloud Storage bucket, and it can only be decrypted and processed on a confidential machine running our RAG stack, right? And when the data is loaded for any processing, it is actually loaded into an encrypted RAM. This architecture actually achieves ubiquitous. So ubiquitous means present everywhere, right? So this architecture achieves ubiquitous data encryption, so encryption at rest, right? Encryption during transit, and the encryption during processing, okay, or encryption during the use, right? And moreover, it also achieves verification that your data is actually or you're processed only on a confidential VM, right? So yeah, so now let's go back and look at the setup and continue with our demo, right? We're gonna see how the data can only be decrypted and processed on a confidential VM. But before that, let's look at our setup a little bit. So here we have a couple of instances. One is the confidential compute instance, another one is non-confidential instance, or the standard Google Cloud instance. Let's look at the confidential instance first. So this is the CKB confidential instance. If you scroll down, notice that it says the confidential VM service is enabled. Then among other security features, obviously it also has the secure boot on. Then if we scroll up a little bit, even the disk for this instance is actually encrypted with a customer managed external key, and I'm using Thales CKM or CCKM as my external key manager. So I actually have another blog that explains and demos in detail how encryption powers the data sovereignty on Google Cloud, and the links to all of this are provided in the accompanying blog already. So if you scroll down, here are those links. Alright, so coming back, we have this confidential instance and we also have a non-confidential instance. So this confidential instance actually runs the RAG application along with its modest UI, right? It also runs the inferencing model. In this case, I'm using the Google's Flan T5 small model available on Hugging Face, right? And then the same instance also houses the vector database. I'm actually using ChromaDB, right? And as we have already seen that even the disk is encrypted with an external key, all right? So here our cloud provider obviously is GCP, and what I'm doing is I'm simulating my on-premises with a Kali Linux instance. So that's basically here, right? So I'm going to use this instance to upload and download all of my proprietary company information. In fact, this proprietary company information is like a synthetic data I actually generated using Bard. So anyways, so moving on, right? So let's upload some data to our cloud provider from our on-premises, and let's see how it is end-to-end encrypted and gets processed that way as well. Alright, so we're gonna upload the data into this bucket, right? So let's go ahead and do that. So I'm going to say gsutil copy, and I'm using state here, which is what client side encrypts the data before pushing it to the Google Cloud Storage, and I'm sending it to this particular bucket. So let's go ahead and do that. Alright, so this file got uploaded. We're gonna go ahead and upload another file, which is list of customers. Now here we are actually sending our proprietary information to the cloud. While sending, it actually gets encrypted and sent out, basically encrypted, client-side encrypted using an external key, and then gets sent to the Google Cloud Storage bucket, and then from there it can only be decrypted on a confidential instance, and that's the next thing we're going to check. So let's go ahead and check the bucket. So notice we have the earning summary that we had uploaded earlier. Let's go ahead and try to open this file. So let's go ahead and maybe double click. So notice that this file is actually encrypted, right? It also says here it's state encrypted, and it was encrypted using this particular key, right? Now we are going to check how this file looked in free text on premises, right? But this is what it looks when it lands on GCP, right? So meanwhile our second file has also gotten uploaded, and we can refresh for that. Here we go, right? Now let's quickly look at how this QN summary looked when it was on premises. So this on premises, this is obviously a free text file, right? But when it lands on the GCP, it was client-side encrypted. Now let's try to download this file onto the confidential instance. In fact, let's try with the non-confidential instance, and then also try with the confidential instance. So let's go ahead and do that. So here we are on the non-confidential instance. So I'm going to say gsutil cp -- state, and let's go ahead and let's copy the name of the file really quickly here, and let's try to download. So notice that we get an error. The file could not be downloaded on this particular instance. This is a non-confidential instance. Let's go ahead and try to do the same thing on a confidential compute instance. So here we are on the confidential instance. So let me go into a new window, bash. So let's repeat the same command. In fact, let's copy from here and paste. So notice that in this case it does actually download the file. So let's go ahead and vim it. So q1. So notice that whatever file was here, it was only same file. We were able to actually download it only on the confidential instance to be processed, right? So that's this is probably the most important part of this demo, is that the file that was sent out was only available to a confidential instance, and it could not be downloaded on a non-confidential instance, and it was encrypted, or client-side encrypted, and kind of traveled end-to-end encrypted to a confidential instance where it will be processed now. So let's go ahead and process these two files. So this modest RAG application that we have also has like a batch processor. So what I'm going to do is so now we only have this about.txt. So what we're going to do is go ahead into jobs, and once we are there, we're going to go ahead and actually run a job to basically load these two files. So I'm going to go ahead and run the job. So this will take a few minutes, and once the files are loaded, we're going to come back. So notice that it says now it has loaded two files, is the list first one being the list of customers, and the second one is the Q1 earnings summary, right? And now if we go to the bucket, right, and refresh, that is, these files are gone from here because they were processed. And now let's go ahead and also check out the knowledge base. So notice that 2 files were added to the knowledge base, right? And then go ahead and come here. Now we can actually ask the questions based on this additional files, right? So let's go ahead and do that. So what was the revenue for Q1? So notice that the answer is 2.5 billion. Again, the context is coming from this one. Now let's ask it a couple of more questions. Who is the CEO? Right? So let's go ahead and ask. So notice that it does answer it correctly. And maybe another question like, what was the CEO's comment for Q1? So yeah, there we go, right? And then maybe let's try to exercise some information from list of customers. So we can say, does Berlin City? So it says yes, right? And then what we can say is, what does Berlin City use ACME services for? And notice that to promote transparency and gather public feedback on policy decisions, right? This is coming from a list of customers.txt. So that pretty much brings us to the end of the first demo. Now, before we look at a speech to text ML pipeline, again, confidential one, using this same setup, I just want to iterate that for most of the customers using Google Cloud's Vertex AI capabilities to put together their AI and ML applications is the best fit. But the customer profile for this particular use case or this particular customer is a bit peculiar, right? So let's delve a little deeper into the customer profile before we go and check out the demo too, right? Well, the customer wants to use the Google Cloud or cloud just as a place where they can run their AI workloads for fine-tuning, inferencing, and various other AI use cases. Again, for reasons mentioned in the blog, why they want to do that. So data goes in, and data or inference comes out, and all of this pipeline is completely controlled and isolated. It's completely controlled by the customer, right? Even though it's running on the Google Cloud in this case, right? So that's that, right? So another thing I wanted to talk about was, why did we kind of choose a RAG as one of the two demos here? Well, that's because of the lay of the land. About 30 to 50% of the NLP, which is natural language processing workloads, are basically RAGs, where the customer wants to question the proprietary information they hold in a natural kind of language, right? Now we saw that in our demo, but there could be patented information and things like that that they want to kind of question on, right? Or it could be the company intranet, which is exposed as a bot, right? Something like that, right? And one thing I want to kind of say here is that this is not the best RAG demo out there, but we are trying to show how you can, or your customers can, do confidential RAG with Google Cloud. Moreover, the customers can actually use their own model, and in our case, we have actually used Google T5 FLAN model. I'll just show you the code a little bit here. So yeah, here notice that by default we use the FLAN T5 basically model, right? And yeah, that's pretty much and then use the transformers library to actually go ahead and load this particular model, right? Yeah, so now off to the next demo, but before we do that, let's understand what we are going to show in the demo. So here we have a few audio files, for example, audio transcriptions, that need to be converted into text, maybe to feed into our RAG, right? For example, the model again runs on a confidential instance. Again, the audio files are client-side encrypted. They land encrypted here, just the way we saw earlier, right? And then they get processed, converted into text, then get encrypted on the confidential instance, and then land onto the cloud storage back, and then from there they are actually pulled down to the on-premises instance, and then they are decrypted there. So notice that the files are pretty much in free text only when they are on premises, or they are getting processed on the confidential compute instance. All right, so let's go ahead and upload those files just like before, and then after that we're going to run the confidential speech to text pipeline. Alright, so here we have these two files. So we are back on premises, and we have 1.flac and mlk.flac, these two audio files. We're going to later hear the contents of these files, and then also look at the contents when they get converted into text by our confidential ML pipeline, right? So let's go ahead first and push these audio files to pushing, which is basically client-side encrypting as before, and then pushing onto GCS. So let's go ahead and do that. So from premises, let's go ahead and push these two files. Alright, so these files are now uploaded. Let's go ahead and check them into the bucket. So refresh here. So this is a different sort of a bucket. So we have these files here, right? And we can actually let's look at this, maybe download this file, one of the files at least, right? And notice that it wouldn't run. The reason for that is because this file is actually encrypted and it won't run, right? So let's go back here. So now that the files are uploaded, let's go ahead and run our pipeline. So running the batch here. So notice that it is copying the first file here, 1.flac. Now obviously in the process it's also, because it's a confidential compute instance, able to decrypt the file, right? So file has landed encrypted pretty much end to end, right? Now it's gonna run the speech recognition pipeline. So it's working on the first file, working on the second file, and then it's sending the converted text files into a different bucket, which we're going to check that a little bit later. Alright, so that really completes our batch, the confidential batch. Basically what happened was we uploaded the files from on-premises instance, which is the Kali Linux instance. They landed encrypted, client-side encrypted that is. Then they were pulled by the confidential compute instance, and the pipeline of speech to text conversion was done. And then we basically went ahead and or the batch job itself went ahead and actually pulled those files, converted them into text, and then created the text files, which are also encrypted, by the way, on their way out, and they landed onto the output bucket. So let's go ahead and check that. And even those files, even though they are text files, they are also encrypted. So your input is encrypted and your output is encrypted as well. It can only be decrypted, or it will only be decrypted in this case on the premises, and also of course during processing it was decrypted on the confidential compute instance, right? So let's go ahead and check that. And all this processing happened on a confidential instance where obviously the RAM is encrypted. So let's look at the out bucket here, the speech out. So notice that we have the speech to text conversion. So let's go ahead and open one of the files here, and maybe double click Notepad. Yeah, sure. So notice that the file is again encrypted, so it has landed encrypted on here as well, right? Alright, so next up what we are going to do is we are going to pull these files onto the on-premises instance, check out their content, and also while we are checking out their content, I'm gonna go ahead and play the actual audio file as well, so that you can match the content with the text, right? Alright, so let's go ahead and do that. Alright, so basically I'm pulling the converted files, and they will also be decrypted. Alright, so we have got the files here, so let's go ahead and cat them. So I'm going to say converted files, and let's say star. So basically these files got kind of shown together. So let me actually go to this converted files and cat maybe one dot flag, and then cat alright, so now I'm gonna also go ahead and play the original audios of these converted text files, so that this was what actually said in the audio, right?
He hoped there would be stew for dinner, turnips and carrots and bruised potatoes and fat mutton pieces to be ladled out in thick, peppered, flour-fattened sauce.
I have a dream that one day this nation will rise up and live out the true meaning of its creed.
And it's kind of interesting that I'm recording this video just a couple of days before the MLK day, right? Quite interesting. Obviously these files come again from the Hugging Face data set. You can actually there's a link in the blog for that, right? Alright, so let me go ahead and quickly summarize today's session. So for most customers, Google's Vertex AI capabilities are the best fit for their AI and ML applications. But for customers who have stringent data protection needs and or want to run their own models in a completely isolated manner, Google provides plenty of options with confidential VMs and UDE, right? And we saw two practical use cases implemented here, right? The one obviously was the confidential RAG, right? That's basically here, right? And then also we saw the confidential speech-to-text pipeline, right? And also you do not have to use both confidential VMs and UDE. So based on your customers' needs, you can choose just the confidential VMs to run their AI ML workloads. All right. So please make sure that you go ahead and check the blog. I've kept it a little brief, because we have covered a lot in the video itself, right? Thank you so much, and happy cloud computing. Bye.